In the kinetic molecular theory, we think of gases as small particles, sort of like a ball. One thing we can understand about the difference between states of matter is that if you think of these little balls in a solid, they're lined up like soldiers marching. They stay in the same place relative to each other. They don't move about. They might shake back and forth a little bit themselves and jitter, but they stay locked up in a tight formation. That's what a solid is like. A liquid, the molecules are just as close together, but they're free to move around, a little bit like a mosh pit where the molecules can slip between one another, even though they're still very close together. Maybe more like a marching band in formation than like soldiers marching in tight rows. However, a gas, they're much farther apart from each other. They're quite free to move and zip about, and they do move quite fast, close to the speed of sound, which is about 700 miles per hour. In the kinetic molecular theory, we think of those gases in terms of being like very tiny balls that have negligible mass and that move around and bump into each other. Sorry, negligible size. They move around and bump into each other. So when we look at them, we can see that they have several properties as they zip around inside their container. And zip they do. One of those properties is pressure. Pressure has to do with it colliding with things. When the particles bang against the sides of this, we call that pressure. That's how we measure it. If they bang more often, that's higher pressure. If they bang harder, that's higher pressure. And if you imagine shrinking this container to a smaller level, then those particles would be likely to crash into the sides more often, and that would be a higher pressure. Another measure is temperature, which is a measure of the kinetic energy of these as they zip around. And as we put a thermometer in, those particles would bang into the thermometer, transfer energy, and we measure it as temperature. So this has to do with the movement of these particles. In a solid, it can also relate to the jiggling of those particles, but in a gas, it can relate to them flying around, the kinetic energy they have as they fly around inside their container. And the last property is volume. And volume is the amount of space that these particles take up. It's important to note that in the kinetic molecular theory, as volume increases, the actual particles themselves do not change in size, but they take up more space overall. So it's a little bit like the difference between having a lot of people in a small room versus a lot of people spread around a football field. The people don't get any bigger, they just take up more space. And that's a brief introduction to the kinetic molecular theory.